And that would be exchanged at the application layer anyway, not in transport layer security.
Right.
And so an indication of, as you said in an earlier slide, you would bind the key into the token, so that sort of you need to talk to this authorization server, and then you could as well tell him, like, along with some of the other parameters you're already communicating when you do the OAuth stance, you could as well tell him, oh, this is the parameters I want to use for the token, because it's actually not the information that the client needs. It's in essence, it's the resource server, the guy you're presenting it to, who will be using those information anyway.
Right. So let me say something to this. Token binding is not authentication. Token binding protects the result of the authentication, protects the resulting token. The way the client authenticates, there are multiple ways to do this. For instance, the client could authenticate using a client certificate. They could authenticate at the TLS layer. In this case, we don't want to burn more round trips negotiating the token binding parameters. This is why we're trying to do it early on and within the round trips of the TLS handshake.
You actually, I think, so maybe I misunderstand the concept based on, because you're using a different terminology here, but so what the parameters you want to communicate from the client to the server is essentially telling the authorization server who issues the token, who then creates this, includes the key inside the token, that the authorization server needs to know that the client wants to talk to some resource server who may be on the same site as the resource server or not. And so the issue of indicating of what that key, so you want to avoid the situation where the client suddenly then, when it proves the possession of the private key, uses a cryptographic algorithm that the resource server with whom it uses that key doesn't understand it.
Correct.
But since there's a relationship between the authorization server and the resource server, the client, when he passes these parameters over to the authorization server, the authorization server knows whether the resource server can actually make use of it or not. So that's why I'm sort of arguing that maybe at the application layer, that exchange would be more meaningful and easier to do than, or more the logical place to do rather than in the transport layers stack.
I see. I think I understand what you're saying. The token binding is used both with the identity provider and the resource server. So in both cases, we would like to be able to bind tokens because both of them may issue tokens.
Right. So I see the case where you use it with the identity provider as a sort of a simpler version than the other case, which appears to me a little bit more generic.
Right.
But yeah. So at least that's the approach we thought that we should be doing it in OAuth. So there might be some possibility for alignment.
Okay.
Just a moment. I'm hearing some of the remote people are not getting audio.
Thanks, Phil.
So, Daniel Kahn-Gilmore, it seems like the only thing that you're negotiating with this ALPN mechanism is the client signaling what specific types of token binding you can use.
Correct.
Right? And it's already a big chunk of ALPN stuff. So there may be, it sounds like Hannes has other goals for negotiating more complex ideas. If those things also get stuffed into ALPN, that's overwhelming. So I just echo that this seems like TLS extension is a reasonable place to at least signal this piece. And if other stuff is signaled elsewhere, that's fine.
Actually, I'm not. So there isn't that much to communicate. You need to tell a few things. You obviously need to tell, like you have on the slide, the algorithms, like what hash function, what is the ECC, or what is the asymmetric crypto system that you're using here, and maybe the protocol you are actually using between the client and the resource server, which is also like indicated here. And then there may be others, like you need to think about co-op if people want to use that in the IoT context. And then it would also be in some cases, in a more generic case, be good to communicate on who the client actually then later on wants to talk to in the OS case. So there's some parameters, but it's not an endless number of things.
Right.
So it's not as much as you maybe think, but it's not just one.
Right, Dave Robin. Thinking about this in OAuth, you didn't start there. You didn't start talking about authorization servers. This is not a three-way thing. You talk about, the server, the client gets a thing, negotiates with the server. It seemed to be that. Is this intended that you're actually talking about a client talking to the authorization server who gives him a token for OAuth purposes, who it is only usable by that client? In other words, I can't give that to some other client and have him use that. Is that the intent? So the resource server side of this is just not part of your discussion?
That's a very good question. So what I'm talking about is just the first draft, that is the basic protocol. Then Dirk will talk about the scenarios with authorization server separate from the resource server. So
Okay,
we call them federation scenarios. There is a separate internet draft that discusses that.
Okay.
We'll
I
present
agree
it
with the
today.
fact that this seems odd to put in the TLS layer because there's two different TLS connections going.
Yes, and we'll talk about how this will work as well. The next
Okay.
presentation is all about that.
Okay.
Microphones and midgets. So I was wondering, and Hannah's kind of opened Pandora's box when talking about the sort of the meta issue about where this lives and how this sits, but I was wondering from a procedural perspective, are we going to talk about that now? Because I
think we can talk about it now. We have 45 minutes after all. So.
I've looked at this, I've thought about this quite a bit. TLS stuff seems fine in its own right, but there's no use for it there. There's no one consuming it at the TLS. All of the activity goes on in HTTP or whatever other protocol.
Right.
So the way that you've chosen to present the solution in two drafts, one with this sort of framework in TLS and the other one with these HTTP things, is actually confusing. And I would recommend that we just decide on the properties that we're looking for and implement them in HTTP. Leave it at that. And then if someone wants to go and do this for something else like XMPP or some other protocol where these sorts of bearer tokens might manifest, I'm trying to think of email. Let's put it in email. I don't know if that even makes sense. But then they can use the lessons that we've learned in the process of building an HTTP solution.
Right. So the first question was, why did we put this in TLS? So this is not in TLS. This is a separate protocol that does connect to TLS in the sense that it uses TLS unique, but it could in principle be used with other security protocols as well. So it's not necessarily to implement this at the TLS layer, and actually, in Windows our prototype doesn't implement this in the TLS stack at all. Then the second question was, why don't we, basically I'm hearing a suggestion to put this all into one internet draft rather than two. Is that, that can be done.
Clerical work, yeah.
Yeah, that can be done.
The concern is, it's an attractive sort of thing to look at the TLS thing and think, well, maybe we should use ALPN or maybe we should use extensions. But when you get right down to it, what you really want to do is have some sort of signal at the HTTP layer that says, I'm willing to sign whatever it is that I need to sign in the following fashion. Now, the obvious thing to do at the TLS layer is say, well, you support you've got the signature algorithms extension and just use that. But that's not sufficient for this.
Right.
So you need something in it, just that, one extra bit of information that says that you're willing to actually do these sorts of things. And again, I'd rather see that sort of thing actually happen at the application layer, with the reliance on the exporters or something like that, or the unique whatever it is that we choose to do to get the necessary hooks into the underlying layer and just leave it at that.
Right. I agree that this can be done in that way, and we can create such an option in the protocol. I think in some cases it will be inconvenient. For instance, when you do client auth with TLS certificates, you don't want to do an extra round trip to communicate the token binding key parameters. So this negotiation with the server at the application layer would create an extra round trip that we're trying to avoid.
Who are you? John Bradley, ping with no chapeau. sombreros, country. So I think Hannes was perhaps overthinking this a bit. This particular negotiation is happening at the lowest level to determine what kind of key the browser or client is actually, what algorithm it's going to use to authenticate itself on that particular TLS connection. And other layers of this then take that key and put it, obviously, if it gets negotiated on a particular connection, both ends agree that they understand the algorithm and support it. The key that gets exported up into some eventual JSON web token, etc., would wind up being compared as a string, not necessarily as an algorithm. So the lower level, which obviously understands the algorithm that was negotiated, would send the TLS unique up. The upper level of the application would compare that string with the string in the token and go, yes, it's good. So there isn't really, we can talk about it in the upper layer of bindings, but there really isn't the need for that complicated multi-party negotiation that the browser and the server need to agree that they both understand that particular, whether it's an elliptic curve or an RSA key. And that's really the limit of the negotiation that we're trying to get done at this point.
Correct.
That the other stuff really happens at other layers.
I am channeling Bill Mills from the job room. How does this work with Speedy or HTTP2, where multiple sites may live behind the same TLS connection?
Right. So Dirk, I think, will speak more to that. But the quick answer is, if the granularity of the token binding key is the same as the granularity of the cookie, and your cookie is, for instance, TLD per TLD, then the token binding will be per TLD, and there is no extra privacy information leaking through this mechanism in that case.
Regardless of the algorithm that we negotiated, we could still have different cookies for different sites.
Yes.
Within the same connection.
Yes.
In response to John, I don't think I'm overthinking it because I just see where the proponents who propose the technology, where they are really heading to. They start with, you guys have an initial use case, which is sort of really the client-to-server use case, but ultimately you want to go somewhere else because you have all this existing infrastructure, you want to tie this into it. And I think many other people will realize that fairly soon, quickly as well, even though you call it secured, there's security token and so on, but we know what these security tokens are. And in the context of sort of the negotiation, I didn't bring up the term negotiation. I see it more as an indication, but the slides, that's what the slide says, negotiation. It's not really a negotiation as such. Our multi-party negotiation, as you, John, phrased it, it's more an indication, but yeah.
So yes, the only reason I call it negotiation is because the client offers a number of options, number of algorithms, and the server decides which one the server is willing to use among those. So yeah. If for now there is no more questions to this specific draft, here are some links and contact information. We have a GitHub page where you can actually leave comments, and then there is some discussion going on there as well. And more questions are always welcome.
Good morning. So I have one question. What's the lifetime for the key?
So the lifetime of the key can be determined in several ways. So first of all, the user can always delete them, right? So the same as the cookies. The user can delete them. Secondly, the crypto layer that maintains the key and protects the key and binds it to hardware or whatever can decide to sometimes purge those keys based on their age, for instance. But that is, I would leave that to the actual crypto layer to decide, because they know what's the key length, how exactly they're protecting the key. If it's hardware bound and never leaves the TPM, always creating the TPM, maybe it can live longer. Those are kind of questions that I'm leaving up to the implementation in the draft right now.
Okay, thank you.
Okay, you said that just like cookies, the user can use these tokens. erasing cookies is not something that users do often. It's hidden in some really, I'm now getting into UI issues here that we usually shy away from, but do we intend this to be more accessible to the user, like having a logout button on the UI that allows you to delete the token and log off, in a sense?
Well, nothing in the draft precludes that. There is no language in the draft with regard to the actual UI requirements for this, but it could be implemented, yes.
I'm sure it could be. We could implement a similar UI to erase all cookies, but
right.
The fact is that we didn't, so I'm wondering if we're going to recommend to do this.
I would not object to such a recommendation. I would not object to it.
In the box.
Good. All right. Hi, I'm Dirk. I'm going to talk through the second part of this. I think we've actually in the discussion here already touched on a lot of the stuff. So hopefully at this point this will maybe serve as a sort of putting it together a little bit. So Andre, basically the way we've split up the IDs at this point is that what Andre just talked about, sort of the generic, maybe abstract concepts, and then the second piece sort of concretizes them for HTTP. So how do we do it in HTTP? These slightly more abstract things that Andre was talking about. And so the tokens that we want to bind on HTTP tend to be things like cookies and OAuth tokens. And I can't really think of anything else. Those are the kinds of things, right, that in HTTP are the kinds of things you would like to bind to the underlying channels, connections. And so the basic idea is that the client just sends along with the cookie or with the OAuth token a proof of key possession that the client does by signing over the TLS unique. Hey, what you doing?
Okay.
Thank you. And the client uses different keys for different servers that they talk to. So I prove to one server possession of a different key, then I prove to a different server. And so where do I put that proof that I possess a certain key pair? Well, I put it in an HTTP header. That's where these generic concepts from the one draft get concrete in the second draft by saying, let's put it in an HTTP header. Now you can go to the next slide. Thank you. So it'll look something like that. We propose the header be called token-binding, and it would basically be the base64 encoding of the thing that is explained in the first draft. It has the signature in there and it has the public key in there, so you know what the correspond. You know the public key, and you prove possession of the corresponding private key. Okay? And so what does it mean then to bind, for example, a cookie? Well, the server at that point just chooses to associate a cookie somehow with this public key that the client proved possession of the corresponding private key of. Associate with that public key. How that is done is left up to the server. If your cookie is some sort of like data structure that is signed and encrypted, you just stick it in there. You sign over and encrypted it. If your cookie is just a pointer to some state in your backend database, you put it in, you add it to that state in the backend database. Okay, next slide. And so far so easy. That's pretty straightforward, right? But as I guess Hannes was pointing out, we are trying to be a little more ambitious here and say, okay, we also want to use this during federated protocols where we have basically three parties. We have an identity provider, we have a client, and we have a relying party. Hannes was using different words. Resource server, authorization server. Yes, sorry. And I'm sorry, I'm using IDP and RP, but everybody knows the mapping, right? IDP is the same as the authorization server. Resource server is the same as the RP. And so there, the problem we're trying to solve there is that now it's not just a server trying to bind one of its tokens to the underlying channel, it's an IEP or an authorization server trying to issue some sort of token, identity, an ID token or something like that, that should be bound to the connection that the client has, not with it, but with this other guy over there with the resource server, right? And because the client uses different keys, there's a problem here. So we're trying to offer a solution for that problem. And there's basically the basic underlying idea is that for privacy reasons, we don't want to, we want to use different keys for the relying party and for the IDP. So the relying party, the basic idea is that the relying party can basically tell the client it's okay that you reveal to the identity provider which public key it is that you're using with me. So that the identity provider now gets to learn two keys, the one that the client uses with the identity provider normally, and the key that it uses with the relying party. So then the question is, how does the relying party signal that it's okay to reveal that public key to the identity provider? And in the draft, we provide two examples for that. One for HTTP redirects and one for using JavaScript. So here's the HTTP redirect sort of version of this. And the proposal here is that the relying party in a HTTP response header basically says, hey, I'm redirecting you to some place where I want you to tell them what public key it is that you're using with me. So the response header here is include refer token binding, right? Which is part of the response headers from a response from a 302 response, redirect response. Quick question?
Yeah, again, Bill Mills is asking, if it's a public key, why do we need the permission to reveal it?
For privacy reasons.
To prevent correlation.
To prevent, and to elaborate on that answer, to prevent correlations of user ID between the relying party and the identity provider. So when the relying party issues a 302 redirect HTTP response, usually then, when the client visits that location that it's being redirected to, send stuff like the referrer and so forth. And if the response included the include referrer token binding header, then what happens? Next slide. Is that next slide. In the token binding, now instead of having just one proof for one key, there's now two proofs for two keys in there. There's the key called the provided token binding, which is the normal thing that just happens if it's a two-party, just between the server and the client. But now the client knows it's okay to also put this other proof in there for the other key that it's using with the relying party, and that's sort of labeled as the refer token binding. It's exactly the same mechanism. You just sign the TLS unique. It's just you just sign it with a different key. Question?
Yeah, Martin Thompson. I've been thinking about this one for a while, and we've been dealing with the idea that the site providing the redirect to the IDP in this case can sling any information that it wants across that redirect, aside from this one thing that you have here. Right? So if it weren't for the fact that we required a signature over the public key that was being used with the relying party, we would simply just say that the relying party stuffs whatever additional information, the public key for instance, in the URL of the referrer in some private fashion, right? Here's the public key of the guy that I'm interested in getting an authorization token for, right? But here you have a signature over that. That's proving something to the IDP. Why? What property does that provide you? Because I can't actually think of anything.
So you get the IDP gets a proof that the client controls both private keys at this point. If you just stick a public key, if the RP just mentions the public key, you could have a man in the middle, for example, between the RP and the client, and the man in the middle gets to choose what public key would be in that payload at that point. And you don't want...
If we've got man in the middles, we're kind of hosed anyway. So that seems a little bit of a stretch to me. So yes, they get to learn this information, but I would rather that they don't get the information unless they actually need it. So what are they actually going to use that for?
Well, I don't want to necessarily dismiss the man in the middle. Like a lot of what we're trying to do here is in fact about man in the middle attacks and making sure that tokens are bound to this client and not to a party that sits between the client and the server. So we are in fact trying to exclude some, I don't want to say all man in the middle attacks, but some man in the middle attacks.
So let me try to better articulate this one.
Mm-hmm.
So the IDP has a relationship with the relying party. And the nature of that relationship is that the relying party relies on the IDP for providing certain authorization decisions and information supporting that. That relationship means that they have some means of passing information between them that can be trusted.
Okay.
Presumably.
Some of us.
Do means what you mean by passing and trusted and so forth, but
let's wave hands on this one as much as we like. But the relying party knows the public key of the person that they're talking to because they've seen proof of that.
Relying party knows of one key pair of the client.
They have a communication channel to the IDP. They have a prior relationship with the IDP such that they know who to send the redirect to and how to pass them information in a way that the IDP can consume it and make sense of it and determine that they need to produce the IWARF token of the necessary shape and form and all of those sorts of things. Why do we need to standardize a mechanism for having the client pass that information to the IDP rather than having the relying party pass that information to the IDP?
Right.
And thereby provide extra information to the IDP regarding the public keys used by the client.
So I think you're asking the same question, right? You're asking why does the client need to prove that they're possessing this key pair?
Yeah.
Right? And the reason is because otherwise it's not clear that it's really the client's key pair. It could be someone else's key pair who's sitting in the network injecting their public key into the communication.
And that would be perfectly fine because ultimately it's the relying party that needs to act upon this information, and as long as the relying party isn't being exposed to anything, any sort of a man in the middle of attack of the nature that you're describing, then the information is useless to the attacker because they can't actually use the token. It's bound to something that they don't. Oh yeah, I think I get it. The attacker says, yeah, okay, yeah. He now becomes the client. Yeah, okay. Right. And so you're concerned about that. Okay. I get that. I'm not convinced that it's necessary, but I get it.
Okay. Okay. All right. Let's see if I can. Let's do next slide. Let's see where we're. All right. Right. So that was the example of how. Right. The question was, how does the relying party signal to the client that it's okay to prove possession of this other key pair that it's not normally proving possession of to the IDP. And so one mechanism was through the HTTP redirect. But federation doesn't always happen through HTTP redirects. Sometimes they use XHRs, for example, to the relying party uses an XHR to trigger calls to the IDP. And so we include another mechanism here that I'll talk about in a moment after I take.
Just wanted to back up real quickly before you move on. A couple of things. Brian from Ping. The federation scenarios where you talk about the redirect from the SP to the IDP, I just wanted to say that it's not uncommon for like a JavaScript enabled auto form post to do that so that you're not limited by URL length limitations and things like that. So it might be worthwhile to somehow account for the token binding header in non-30x type scenarios.
Yes.
It complicates things, I'm
Right.
sure, but
Right.
a consideration I think might be important.
Yes, yes.
And then I don't have a good answer, but I wanted to just make a comment that when you said there's a straightforward mapping between SP, or resource server and RP and AS and IDP,
Okay.
that's generally true, but there are some scenarios, especially like in OpenID Connect, where an ID token and an access token are transferred, where the roles get shifted around, and there's the client is the browser in the case of the ID token. So that's kind of the federated three-party model that you said, but in that exchange, there's also an access token that could be used to shift it around, where the RP itself becomes the client with respect to some system back at the authorization server that may not actually be the authorization server, but related to the authorization server.
Right.
So I don't know how that all plays in, but it's maybe an important distinction beyond just the simple, there's a mapping.
Yes, yes.
Which is true, but not always.
Right. So to address the last comment first, yes, I realize things get more complicated. The scope of the IDs that we have in front of us today tries to accomplish token bindings of tokens between the clients, the browser essentially, and the servers. It doesn't really address binding an OAuth token that would ultimately be delivered to the relying party that is used in some back channel back to the IP or something like that. Right?
I think so. That probably makes sense, but it's probably worth clarifying.
Yeah.
Talking about things.
Yeah, good point.
Honest OAuth, and it gets muddy pretty fast. So I think it's a useful clarification.
Yes. So So keep in mind, for now, what we're trying to do is something that the browser sends to a server that's token bound. What servers do amongst themselves, relying parties to service providers, not trying to tackle these. It might be. First comment you made, yes, I have a slide about that in a moment, and I do welcome any ideas about the post, right? An auto post. I welcome ideas, comments on that.
Just that needs to be thought about. One here, can you back up one slide?
Okay.
When we were talking about, I'm coming at it from the application level down and up, so some of this is a little fuzzy to me, but in the referred token bind, the signature with the TLS unique, is it, whose TLS unique, and does this actually prove to the, to the IDP in the case? What does it prove? I'm sorry.
No, good question.
Can you understand my question and repeat it?
Yeah, I think I understand. So the question is, since there's two TLS connections going on here, one to the IP, one to the RP, what are these TLS uniques that I mentioned here? Because there's two of them. And there's not two of them, it's the same one. It's the one between the client and the IDP. So, what is being proven then, if it doesn't seem to think about that other TLS connection, but what is being proven is that this client controls these two private keys. It's not a statement about the other TLS connection, it's a statement about which keys the client controls.
Using the TLS session with the IDP.
Yes, and so they happen, the way we prove that we control these keys happens to be that we pick the TLS unique and we sign over it.
That clarifies it, thank you.
Okay. All right, forward. Right, so this was the second way of signaling to the client that the proof of key possession for this other key that they're not normally using with an IDP should please be provided to the IDP. And so in XML HTTP requests and this API that exists today, there is already a bunch of sort of flags you can set before you fire off the XHR. And so we're saying, well, let's just invent one more flag here that you can set that says, because so this JavaScript would be executed by the RP, right, in the origin of the RP, which is preparing in this example snippet here an XHR that gets fired off to the IDP. So they can add a flag here that says, by the way, it's okay that you include this extra refer token binding in that header that you're sending to the IDP. Question?
Okay, channeling Bill Mills again. Why would a client ever assert a second private key that he doesn't control?
The client controls the private key. The client controls a bunch of private keys, different keys for different origins it talks to.
So the user agent, so client means something else in OAuth, which
sorry.
is...
Yes. So John clarified, when I say client, I mean browser user agent. I don't necessarily mean OAuth clients. User agent.
Bill was clarifying that he meant a second public key, but that really doesn't change the answer.
Right, so the user agent controls both of these key pairs. In fact, the user agent controls a lot of key pairs, each for each server it talks to. And so in this example, one of the many servers it talks to plays the role of an IDP, and another of the many servers it talks to plays the role of an RP. So these two corresponding key pairs are the ones that are that sort of play center stage here in this exchange.
I have one quick question, John Bradley, again, which you confused me slightly on this slide. You said that there were signatures over the same TLS unique, but I believe those TLS uniques are per connection because they're the public key.
Yes.
Okay, so there's in that slide, there's two different TLS uniques, each signed by the corresponding private key.
No, same TLS unique. For that one connection between the user agent, called client on the slide, between the user agent and the IDP. There's one connection between the user agent and the IDP.
It's one connection, but is the second TLS unique the TLS unique of that connection or of the connection to the TLS unique of the other connection signed by the other connection's private key?
The former. It's the TLS unique between the user agent and the IDP. Because remember, the TLS unique here is the thing that we pick to sign so that the server can verify the signature.
Okay, so it's the same TLS unique in both of those, that's signed in both of those, but by different public keys.
Correct.
Okay.
Yeah, I mean signed by the private key, obviously. Yes.
Right.
Yeah, I mean we could have done like a challenge response or something, like some way to prove that I'm possessing this key, and it turns out TLS unique can be used for this without introducing additional route. Next. Open issues. So Anna on the GitHub page that we have pointed out that XML HTTP request is old news and fetch apparently is the new hotness. So we should do all this for fetch instead of XML HTTP request. That sounds fine to me, but I don't know much about fetch and XML HTTP request. Like, is it really on its way out? And then this second point here is something that somebody, I forget who brought up earlier, is like, so redirects in XML HTTP requests are two ways that IDPs, that we do federation today. But are there other ways? Are there other, common ways to do this? And if so, what do they look like? Other mechanisms do you need to get this federation stuff going?
Yeah, so Martin Thompson, I can speak to the fetch thing. We're doing our very best to get to the point where we can deprecate it, and part of that process means that we stop doing new and wonderful things to it.
Deprecate the old XML HTTP
request.
Yes.
It's an abomination, and so adding new things there would be counter to that strategy.
Okay.
So
not be on fetch.
This actually,
that's something you need to take up with the W3C.
Right, but if you remember, so this is one of the things that we identified as process issues. We need to get somebody or somebodies from W3C, to review this, right? And we would prefer not to have to resort to formal liaison, yada yada, right? So is there like people who, for instance, yourself, who could sort of take point on getting enough review from W3C to say yes or no, do this, do that, right?
Yeah, so I think this is really just a matter of going to probably the web AppSec working group and sending an email, and there are people there. I mean, I don't imagine that you will have any trouble getting Mike West to respond to that email, and there's a bunch of people that are quite happy to review this. Once I think you get to the point you're happy that this working group needs that particular mechanism in place, and I think that just thinking through sitting back here, I've been convinced that this is probably the right way to do it. So do that.
So it sounded like you volunteered to.
I can do that.
Thank you. So
I'd rather that Dirk or Andre sent the email, to be honest. But
okay, I mean, whatever. I mean, I just want to make sure that the W3C people don't come in here with pitchforks and try to, you know,
No, Wendy Seltzer here with W3C, and happy to help in making sure all of the communications happen. I think informal communications with the WebAppSec group and Fetch is over often what WG but land, but also in fine communication with us. So we can happily talk about pieces.
Okay.
Thanks a lot.
Right. So you know, I could have probably spec'd out how this would work with WebSockets, but I don't really know that anyone uses WebSockets as a federation, you know, during federation mechanisms. Yeah, there's the auto form submit. It's a good question. How?
Well, XHR versus Fetch is not just, sorry, here on Schiffer, it's not just a political question, like 99% of the world is still using XHR. So if you actually want the technology to be deployed.
Yeah, but so I'm not too worried. Like if Fetch is something that is actually happening and will show up in browsers like soonish, I personally am not too worried about it, because in order to move to bound ID tokens, RPs and IDPs have to sort of rev anyway.
Yeah.
Like, so they might as well then move to this new thing at that point, is my opinion. But
yeah, but if there are tons and tons of JavaScript code using XHR, they're not going to move to Fetch just because they're going to get this shiny new authentication thing.
Right, it's probably the other way around. They decide that they want the extra security from bound tokens, and then now they need to figure out what do I need to do in order to do that, right?
Isn't it all using jQuery anyway, so it's like up to them to fix it on the shim layers?
Or maybe it shows up in libraries that people use.
Daniel Kahn-Gilmore. I have a couple questions, and also want to channel Bill Mills from Jabber, who's asking, Bill Mills asks, is the HTTP server assumed to have access to the TLS unique value? Does the HTTP app layer recheck the signature?
So the HTTP server,
I mean, I think the question is about, like, what if you're behind a load balancer? Right, HTTP server, you don't see the same TLS unique value.
Right. So I can maybe speak a little bit how we would build this at Google, where we have TLS terminators, and then we have the app server sitting behind those. I guess load balancer, TLS terminator, same thing, right? So the TLS terminator would verify the proof of key possession, but because it's given the public key, it's given the signature, it can verify that the signature verifies with the public key it was given.
So it knows enough about HTTP to see that, to extract the proof of possession from the HTTP header.
Yeah, so it would have to look into the HTTP header at that point, right?
So your TLS terminator is now an HTTP stack as well, HTTP2 stack?
That's what we're doing.
Okay.
The alternative would be to simply sort of send the TLS unique downstream, right, to the backends, and have them do it at a higher level. Either way is possible.
Okay. So So one question is just, are we continuing to propagate the refer misspelling in the headers that you got here?
Why, of course.
Okay. I'm not sure why that's a good idea. I don't know that it matters. So are you also, are you making this dependent on the TLS session hash fix? Because TLS unique is broken without that.
Right, this is the same as the extended master secret?
Yes.
Yes. So there's language in the IDs that says this must be co-deployed with EMS extension.
Okay. And so then to go back to the discussion we were having initially at Andre's presentation about why you guys want this in the TLS handshake, just to clarify, the reason I think that you want the negotiation in the TLS handshake is because you want to know the capabilities of the server before the client decides what to send in the HTTP header. Is that correct?
Yes, that's correct. And also the ability to negotiate token binding, as you've mentioned, depends on the ability to negotiate extended master secret. So there are some properties we want in the TLS connection for all of this to work.
Okay, Charlie, Bill Mills again. How do you defend against header forgery from an attacker?
Against header, how is the attacker forging the headers?
I don't know. But since I'm already at the mic, I'd like to raise the issue that nobody's talking about TLS proxies. As soon as you have a TLS proxy, you're going to have a different TLS session. So if you're binding to TLS unique, this method utterly fails, whereas the old cookies work perfectly.
Right.
So
right.
What are we going to do about that? Because TLS proxies exist, we can't just ignore them.
Right. So there's a couple different, I guess, scenarios that could play out here. One is that you're sitting behind a proxy and never move away from behind the TLS proxy. And so what the server will see at that point, presumably, is whatever the TLS proxy asserts. Probably they'll be serving SSL version 2 or something, because that's what they tend to do. But if they're just old and they never change things. Anyway, so if the TLS proxy speaks this protocol, the tokens will be bound to whatever the TLS proxy chooses to do. And so they'll be bound essentially to the TLS proxy to the real client, right? But actually, more likely in practice is that you don't get bound tokens because these TLS proxies won't support this stuff. And nothing really breaks. You get unbound tokens, you get tokens that are bound to the proxy. It gets more interesting if the client actually moves from behind that proxy back and forth, right? So now if I say I get a bound token while I was not behind a proxy, say I logged in from home, and now I go to work where I'm behind one of those enterprise proxies, right? Now all of a sudden, essentially the server will now treat my cookie as invalid, right? And I'll see a message that says you need to do it again. That's the extent of the disruption that'll happen.
So it's a good property that you, oh yes, you're behind the proxy.
Yeah, you're like, we logged you out because your connection is no longer secure.
Okay, so now Bill Mills explained his question about the forgery of headers. Isn't the TLS layer inserting the talk binding header?
No, it's not the TLS layer. It's actually the HTTP layer. And I didn't mean to sort of be crib about the answer. I just didn't know what attack model he had in mind. So you must make it impossible, I guess, for the JavaScript to just pick the header, right? That's why instead of saying in this JavaScript API version, you don't get to say what the header is, you just get to flip a bit that says, please insert the header here. And it's not the TLS layer either. It's, I guess, the HTTP. But I don't know how that answers the question either, frankly.
So then there is no actual binding between TLS and HTTP in the proxy case.
In the proxy case, there's no binding between us.
I think we're having two conversations in parallel here.
If someone can interpret the question for me, I'll try and answer. Does anyone know what the question?
Well, if there is a TLS proxy, then there's no binding in what we described.
So you lose certain security properties if you're sitting behind the TLS proxy.
Yeah, if you're trusting a TLS proxy, you might as well trust the proxy to also maintain your session.
Yeah.
And that sounds like the Google answer also, is you trust the proxy.
So there's a different proxy. There's the TLS.
Because their proxy is really owned by the same people who own the service, so it's more, it's a more convincing argument.
So your name at the mic.
Brian Smith, and I'm actually going to ask similar questions about proxies and interception while being in the room, so maybe I can try to explain in person. There are proxies that are like CDNs that have issues with client certs now, where all you can do is terminate the connection with the client cert and package up the client cert into an HTTP header and send that forward. And this looks to inherit the same usage model, where if you have some sort of intercepting proxy like that, all you can do is shove it in an HTTP header and try to explain to the origin server what it's supposed to do with it. And that sounds like what you're talking about, where you have TLS terminators. But because this binds to the TLS unique as opposed to doing it at the application layer, it seems like this is going to have really bad instability issues. If your model is that people are either at home without a TLS proxy or at work where they have a single intercepting proxy, I worry what happens when someone uses this in a world that's flipping them around between different load balancing intercepting proxies every 30 seconds or 2 minutes or so. It's going to feel a little bit like trying to use some protected websites over Tor, where you're seeing a CAPTCHA every 30 seconds or so because, oh, you got a new IP address, here you go. I think this is going to have a similar issue of, if the idea is that it's going to bounce up to the user and ask them to log in again, that the experience is going to be really bad when we could provide a very similar security model without the bad user experience by putting it at the layer. In a way so that it's proxiable through, where a designated man in the middle, who is trusted by the origin provider, can proxy this through in a way that provides that there's a particular legitimate end user at the end.
Yeah.
Where you go to the TLS, that man has to break it all the way, and I think you get a less good equivalent security properties with a terrible UI.
Right. Good point. We should see whether how prevalent jumping proxies are. I don't think we've looked at to see how big of a problem it would be. And the solution you're proposing, I think, is sort of similar to the discussion we had earlier on, is can we somehow get this out of the TLS layer into upper layers? And I'm certainly, I'd like to see proposals to see whether we can do this without introducing round trips and so forth. I mean, we have thought about this a lot, and that's what we're up with as the thing that doesn't introduce more round trips. But if anyone has any ideas, I'm all ears.
Yeah, so Martin Thompson, the only way I can think of solving this is by introducing a challenge, essentially. And that means
more round trips.
And that's why you're using TLS unique. I mean, there's some interesting properties with respect to being able to detect a man in the middle, but there are, as Brian points out, certainly cases where that man in the middle is present, and will either have to generate their own token binding, effectively spoofing the client existence.
Right.
And then subsequently you look like someone different at that point when you're behind that proxy as opposed to not.
Right.
Or they have some sort of additional private communication channel with the ultimate origin that allows them to signal what they saw in a way that the origin can actually trust hasn't been modified. So you can imagine lifting the signature off the connection. Some object that you stuff in another header and send it onwards, which is a sort of that again that Brian's talking about with the client certificate stuff. So I don't know if you want to solve the problem for these guys doing the CDN case, or whether you want to leave this to sort of private solutions or not, but make it.
Right. Yeah. I mean, I see that doing it completely at the HTTP layer has certain advantages. Like the proxies like the proxy problem being one of them, but yeah, I don't think that I would like the extra round trip, and from the data that we've been looking at, we don't think it's going to be a massive problem logging people out if they're moving in and out from behind proxies. We see it, but we don't see it that much. If you're behind a proxy, you tend to stay behind the proxy. I mean, statistically speaking, there are people, of course, who move, but.
Vinod from Google. Just want to clarify that the binding is actually to the private key, not to TLS unique. TLS unique is just right. So even if the user agent is actually hopping across multiple content servers, the TLS unique to the servers might be changing, but the binding of the token itself is not. So there's no reason to log the user out, right? Because the binding will be to the private key of that the user agent possesses, right? The TLS unique is just to prove that this key is for this connection, which should be fine for that.
Brendan Williams, Akamai. I'm a little bit confused by what you just said, because I thought that what I heard earlier was in the proxy case, the binding would be associated with the proxy's key, and so the proxy would have to be in a position to generate the cryptographic signature. I misunderstood that.
So, Andre, you stand up and answer directly at the microphone.
Sorry. So the answer to that is no, the server is not able to do that because the private key is only present in the client, possibly in the hardware security module. So there is no way for the server to do any signatures with that key.
Yeah, but I think the problem was that if I'm in a situation where I'm behind like 100 different proxies, client-side proxies, not the TLS terminators on the server side, but client-side proxies, and I'm being, sort of load balanced that way, and my connections show up from, round robin from each of these proxies. The client-side key is not going to be the key that's going to be useful at that point to the server. Right? The proxy has to decide to either not do token binding or use its own keys for token bindings, and I think it's that latter case that people are pointing out, well, if I'm load balancing through 100 proxies, they all create their own key pairs, then I look like I'm using 100 different key pairs for the same origin, right? Because I look like 100 different clients. Right? That was the issue.
Even forget about the load balancing case, just the straightforward proxy case.
Yeah.
It's the TLS unique. I mean, does the TLS unique have to propagate forward from the client through the proxy connection as well, the TLS session between the proxy and the server side?
No, I think for this particular question, the TLS unique is a bit of a red herring. It's just a thing we use to prove key possession, right?
Well, right, but it's a signature over the TLS unique is involved in that proof, but if the TLS unique is different between the proxy and the server,
you need to resign it, right? Yes, and it better be different, right? And that's what the EMS extensions for, to make sure that these things are in fact different, right? So yeah, the problem I think that we're putting our finger on here at this point is that it's the keys that because they can't leave the client and they shouldn't leave the client, right? The proxies now get to pick their own keys, right? If they wanted to do token binding.
And would the proxy end up having a different token binding identifier than the client?
Yes.
In which case, I'm confused about how things would work at all if the OAuth, in the common case of the OAuth server and the client being on the same enterprise network, and therefore the client doesn't necessarily go through the proxy on the way to the OAuth server, and therefore, there's no place for the identifier to somehow get changed on the way to the OAuth server so that the correct binding identifier. It's very confusing and complicated.
Yeah, I guess my sort of gut reaction would be that if you're in a setup like that, you're not really binding tokens to the client anyway, right? The best that you end up doing is binding them to your proxies,
right?
Which isn't really what you were hoping for. So my gut reaction would be, in this scenario, just configure your proxies not to do the token binding, and you just live, you live in the good old world that we live in today.
Daniel Kahn-Gilmore. I just wanted to use the word man in the middle instead of proxy, and acknowledge that maybe trying to make all of this stuff accommodate man in the middle is we shouldn't tie ourselves in knots to accommodate a man in the middle for a protocol that is supposed to be a secure authentication protocol.
Sounds good to me.
Speaking on my own behalf, Mrs. Yadmira, we can't deploy stuff that relies on man in the middle not being there. You can't deploy such applications on the web. And now, channeling Bill Mills, when does the HTTP server actually check a signature?
When does the HTTP server check the signature? So it needs to be, so the HTTP server, as I think you pointed out earlier, right, itself can be split into several roles, right? The TLS terminator, application backend, and so forth, right? So the signature check needs to be done by somebody who has access to the TLS unique and has access to the token binding message. When does it happen? So it needs to happen, as you process the incoming HTTP request.
Is that with every request or just the first one?
So every request carries the header, and so you check for every request.
Okay.
Yes, so Martin Thompson, you can optimize that out, obviously. The token binding is going to be the same. Well, DSA aside, the token binding is likely to be the same for every single request on a given connection.
Right.
And you can cache the result effectively, and that will allow you to amortize the cost over the lifetime of the connection.
Right. I think
unless we're signing every single message with a different DSA signature, and then good luck to you.
Yeah, I think in particular in HTTP2, I think there's an elegant way to solve it by just using the header compression mechanism that exists there. In HTTP1, it's a good, we should maybe think about a way to optimize that piece out in a similar fashion.
John Bradley, Ping, No Hat. Couple things I'm curious about. In a lot of the conversation and in the previous presentation was said the key should be stored in a hardware module and not exportable, etc. But there appears to be in conversations differing expectations about what applications, is a native app that's doing OAuth going to be able to get access to the same TLS connection or keys as, say, the Play services, as, say, the system browser? Are you planning security considerations to at least document that this might be implementation specific, or are you planning on having mandatory to implement these keys aren't exportable, etc.? How are you planning on dealing with the differing expectations and perhaps different environments as to whether or not, yes, if you are a JavaScript client and you happen to have web crypto enabled, you can export that key and do something with it? Somebody may decide to do that. Are we going to say that that's perhaps a bad idea? The other is, my other question is, there's two different ways of doing, in the blog post I did about how you would use token binding with the OpenID Connect ID token. There's sort of two options on how you do it, and they have slightly different security properties. One is only sending the key in the client key in one direction. The other is sending it to the authorization server, but also sending the authorization server's public key back in the other connection, so that you actually are protected a bit better from one type of man-in-the-middle attack. But on the downside of doing the second, of higher protection, is that you're also providing a correlatable handle. So there's also privacy considerations that perhaps need to be, and the privacy people are going, of course. So are there going to be some guidelines that you're considering around whether or not the user needs to be at least informed, or perhaps give some sort of consent when some sort of correlatable action is taken, i.e. I'm a bad site, I have central bad site, I bounce somebody off of that and have them return the key, and using exactly the same mechanisms you define for the doing proof of possession for an OpenID Connect ID token. If you reverse that and were a bad person, you would have a really great super cookie. So we need to perhaps have some consideration about whether or not browsers should signal that there is a central site that's using all of their cookies, and or somebody a way of saying, these are known bad sites that Microsoft or Google or somebody is collecting, so that the browsers know to try and bring it off, or users have some sort of consent. So there's probably some group of security and privacy considerations that need to be in these specs, which I don't think are really flushed out now. What are your plans for that?
Okay. So plans are, as a group, we come up with these set of recommendations. I can tell you my personal opinions on these things. But, it's up to us, I think, to make sure that these considerations are in it. I agree they should be in there. The first issue pointed out is like, what do we say about how these keys should be protected? And, should native apps have access to them and so forth? I would argue that, they shouldn't be extractable from a, because one of the models is that in fact JavaScript you're running was affected by a man in the middle, and so I don't think up to level JavaScript should have access to the private bits. On native apps, I think the question is a little more complicated, because it's depends on your platform, I guess, how good support you have for this kind of stuff. I understand your question was more multifaceted than that, but so those are just 2 points I guess I would maybe have an opinion on. But think through all the facets of the points you brought up in the security consideration section. The second part about how opinionated should be about how federation protocols actually make use of this stuff and other privacy applications. So the fact that the relying party in this proposal reveals relying party related information to the IDP was a conscious choice, because I felt that an IDP already, so an asymmetric power already going on iterated systems. IDPs usually know where the user is logging in. They know the user ID because they're the ones meeting the user ID for the relying party and so forth. So I felt that there's no additional sort of information leakage from a privacy point of view if the relying party allows the client to reveal relying party related information to the IDP. But it's not necessarily the other way around. The RP doesn't necessarily know what the user ID is that the user has with the identity provider. And so that's why I did it asymmetrically like that, because of fact privacy considerations. But again, right, that was just my thinking that went into that. If we have more input into that, it would be great to make sure that we get this stuff.
Andre Babov, I also had a comment to answer John's first point about native applications, JavaScript, and so forth. I think that the token binding key really goes with the token itself. So if your platform allows the sharing of the tokens between native applications and the browser, for example, in order to achieve a single sign-on between native apps and browser, then that platform will probably share the token binding key between those as well. So if the platform shares the cookie between applications, then the platform will probably share the token binding key between those applications as well. So that decisions seem to be platform specific, and I think it would be really hard to standardize, the way those things are done with different platforms, but we can certainly get some guidance on this.
Right, this is, and I remember I wanted to say, yes, the security session, there are probably a lot of mays and shoulds in the security section, I would think.
So that sort of was, I'm not sure if you can step out of the box. Feels better, like relaxing. So that sort of leads naturally into sort of my little bucket list here. One of the things that sort of seems clear from this discussion is that there will be some issues to manage here, and that I think it's probably a good idea for us to have a little bit of issue tracking going on, so we can keep track of this stuff. I propose that we keep the issue tracker that you guys already started on GitHub. I would suggest, and we have a conversation about this later, but I would suggest that you guys consider putting source for your drafts in whatever format you use, so that people actually give you pull requests to provide specific text suggestions. I think that might actually help to make things go quicker. Neither of you brought up the question of working group adoption. Working to charter explicitly says that we're starting out with this document. It doesn't say that how and when and what form we adopt them. So I think it actually, I mean, Martin Thompson, you brought up the notion of maybe joining this document. It doesn't include doing that at a later stage just because we sees this working document. So I'm going to do a hum right now and get us whether there is support for adopting these documents as they are as working group documents, and we can keep going on them. So hum now if you support these documents as working group documents. Hum now if you support them. And hum now if you feel more information. Okay. I'm getting that. Perhaps. How many people read the version 0? Any version of these documents? Okay. It's pretty solid. Yeah. What we'll do is when I authorize the tracker, we can publish the next version. Oh, I did it? No. So the next thing, so I'll send out the list to the mail to list saying basically, go maintain issues for these documents at the GitHub site, and whether we can look later about sort of pull requests and how to handle that. So the next question here is milestones. Right now, the document milestones are, I guess, made up. There's January, arbitrary made up sort of. It says January 2016 for doing everything. So the question is, whether that's you guys want to move it around? Is it what? I mean, it's sort of that. This is sort of a question for the current editors and also what do you think is a realistic goal to shoot for?
They don't both need to be done at the same time.
No, pretty well need to be done at the same time. But I'm not sure that it's worthwhile keeping a difference between them. So I would actually be inclined to leave the milestones as they are for the next couple of months to see how it progresses. I don't know that January is either a realistic, really extremely optimistic thing. I have no sense, because it all depends on how many issues we're going to have, how much discussion we're going to have. So, you got to have opinions too. Can we add another zero to the year or what? What do you want?
Big item.
substitute for the question about my friends, and they're always fictional. It's always true. However, the idea is not for this work to be around for a very long time. So I would actually appreciate it if you could try and see what you guys are aiming for. And I would encourage you to try and aim for something that doesn't involve, I think Jim said 2020 or something. I hope you don't say that. So I'd like you to kind of have a target and then try and get those on a mission. Because
I think given the amount of discussion we've seen today, I would say that it's probably not realistic to have this done before summer. Right? I don't think that's going to work. I think having it done by fall, maybe like October, maybe. If you guys are comfortable saying let's shoot for November to get everything done, I think there is not that much value in keeping like 4 or 5 separate licenses for different stages of this. I would say, let's say to do November for finish everything and send it up to the FJs, do maybe January for publication.
I'm very proposal. I'm not really predicting dates, saying when things will be done in the future. But so based on the current frame that we have, right? We have a number of issues that can address in the drafts. That will take us a little bit of time, but by the next IETF meeting we'll have that already, submitted. Then there is, based on the discussion, there's an ask to create a new TLS extension to negotiate the token binding key parameters. That will need to go through the TLS working group, I'm assuming. So that will take some time, probably. Usually the TLS working group things don't happen very quickly. But at least, I'm hoping to have all those updates and the new TLS extension draft by the next IETF meeting, basically. That would be the next milestone. And then, depending on how that goes, we'll know the end date better.
Robin tells me if we're going to create a dependency on something that's happening in TLS, I mean, if that's your plan, I would suggest that the dates that you have are removed, but I don't think that's necessary. So I think we could probably, this is all the right people are here. Defining the extension here or in the document that's been adopted, I don't think is perfectly helpful.
I mean, can we just do cross-network review and then extension we create here? I mean, I was actually asking that of Stephen, what do you think? All right.
This is Barry. If another unrelated AD can just absorb into a minute. I'm not a big fan of having the ADs drive the milestones and tell you what to do. It's your planning. What's the real key to getting this done is the chairs pushing the authors pushing the working group, and getting the decisions made and getting the work done. And if you're actively doing that, work is progressing, then you're doing the right thing. That's the important bit.
So the only other time would be any interaction with WebSec or so I don't know when is that. I'm looking at anything at yeah. So I think either we're going to write a piece of text that changes their spec and get them to okay with that, or else we're going to write a piece of text that says you would like to have an API that does this, so suppose that they would actually go off and do that, change their spec. I think those are the 2 simple options, right? The second one, I think maybe could allow us to be independent of their plan. The first one makes us independent.
What that second is just recharged with a bunch of exciting deliverables, and so I think probably as independent but sharing documents is probably.
That doesn't like maybe what.
I don't see a dependency.
We don't take that now. We do the question is whether our document will have normal text change with yours, or whether we write the prose that says the kind of change we'd like, and then do that.
You're talking specifically about fetch? Such isn't even ours. That's the issue.
Try and isolate ourselves from that. I think it sounds to me like we could have no pros. That's what we would like to see. So I think not include an essay document in the text, but somebody needs to go there and get it.
Okay. I think we have this question about timelines. Could be very little bit, because I would like to get your input definitely about what you think is achievable, and then we'll move up with the charter tomorrow at extent also for working group. I think that was mine. So we're at open mic time. I mean, so we have like a entity applicant here that is is interested in willing to talk to us about finding, but we would be glad if anybody has any idea to raise those things to do that. Jeff, Jeff. I'm going to come over the for simplicity. Oh, just you want we can okay.
Is this on?
Yes.
Okay. So there's a couple of options here. There's several folks in the room that are involved in it, not just me. Aaron's pointing over here at Jim, so I'll stand right over here.
Yes.
Sorry.
Because I'm not, doesn't
so the object. So there's a couple of aspects to this. There's I don't know if people want to hear a visionary fighter speak.
What can you tell us about how token binding impacts IDA?
Well, there is another piece of...
Right, just to tell the folks who are and ask you to speak about something that you decide what exactly you want to talk about.
I will point out that Dirk has some stuff on this too.
That's
one of the presentations.
Yes. Yeah. So the reason I asked Jeff to talk about FIDO is that there is the token binding specifications are part of a larger architecture. It's being talked about very important. I think it's important for the IETF to understand how the stuff fits in with the larger pictures you see the whole board. And as soon as we are able to double click on something, and nothing happens, and we didn't. Is that what you want to? You wanted?
Yeah.
You wanted the other one. Okay.
Well, I don't want to do the other one because the other one's Dirk's.
Well, just try to get me to bring up Dirk in presentation. Well, you can get him to do. Okay.
Okay. So
I would produce.
All right. Do you want me to stand in the box?
Yes, please. Here's some of the books. Some language to compose to that. I don't like helping out.
You're supposed to stand. I thought it did it worked on its own.
All right.
Maybe it doesn't.
It's never going to focus on anything again.
Okay, but I just want to. Okay, so just a quick overview. This is a gnarly technical one. I did quickly find more of the marketing priest. So this has some. So to back up, the whole, yeah, you could go there. Just stop. Thanks. The genesis of this stuff is phishing highly prevalent, as we all know, on the web, because and not just on the web, the internet, because we receive massive emails every day that are saying, please click here. Right? You need to adjust your Facebook account, or you need to reset your password here. And the reason for all this stuff works for the bad guys is we all wield reusable shared secrets. And human managed reusable shared secrets with these entities out on the network that we deal with, and they're easy for people to trick us into fooling, to trick us into disclosing them to third parties that have bad intent. And we all know about this, and it's big bad problems. How do we fix this? People have been trying to figure this out for a long time. This has been known for a long time. If you manage key store on the client side and kind of automate it, and you hand out asymmetric keys, hand out public keys to each individual entity that you talk to, and the user has some means of managing the key store, then you're not using shared secrets anymore, and you can hand out that if someone intercepts this thing, it's not going to be good because it's just a public key. So costs have come down, and technology has gotten to the point that we can make this happen. And so this UAF is universal authentication framework or something like that. That's what we have stations for. I guess we originally were contacting this stuff. Also U2F, which is Google's Nubby, and the came into the tent and stuff that brought the Nubby stuff, and we ended up calling it Universal Factors because it's more streamlined, less extensible, aimed for a second factor kind of user experience. They're very similar. The result is that you do not have a phishing, and that's the main threat model that this is targeted at. And so the quickest, we got a bunch of people together that were launch party. There was a biometric vendor and people that did crypto kind of stuff. We cooked these things up and started getting it going, blah, blah, blah. And having an IPR model, mutually assured destruction. PayPal has, if you have a Samsung Galaxy S5, you can use this PayPal account, and it's been shape-rolled. Google launched their stuff publicly in October. It's been being used internally for 2 years, something like that, long time. Adam Langley demonstrated Google at an IETF meeting, I think back in 2013. I'd have to look at my notes. Anyway, so how does it work? This is the user experience, basically. This could be the PayPal thing on a Galaxy S5. You want to pay or transfer, you swipe your registered fingerprint, your registered finger, whatever, and it works. And under the hood, there's basically a single round trip challenge response protocol. And the presumption is that on the client side, there is asymmetric key pair generation on a per entity basis, entity that you're talking to. And the key store manages that transparently for the user.
not unsurprisingly, in terms of this has been cooked up before and blah, 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 Stephen Farrell's HOVA stuff is extremely similar. So the spec and this was independently cooked up. I don't think the people who I didn't do the initial work on this, on FIDO. I kind of got dragged into it after it had gotten fired up and started by the initial founders. So independently, Stephen had similar ideas, and there's if you go look through the literature, people have known about doing this sort of thing for ages. There's tons of prior art. It's just it hadn't been widely adopted or standardized at this point. So, next. So this is what I've been hand-waving about. You've got authenticators are the device, the thing that's embedded in the user's system, phone, laptop, whatever. Maybe it's a fingerprint reader, maybe it leverages the camera to see your face or whatever, manages keys, deals with relying parties.
Oh, hang on. Hang on.
2 fingers?
I don't think so. Oh, there we are.
Yeah, got it.
There we are.
Right. So there's 2 steps when you first deal with and we use the term relying party. We should call it FIDO relying party. Okay. A FIDO relying party is just a 2-party interaction. And for those who have federated identity management protocols in their heads and stuff, in the federated identity interactions, there's always this line between the user system and the IDP, where we say, and I work on SAML and blah, blah, blah too, where we say authentication happens here and it's out of scope from federated identity. FIDO is that line, okay? If you're in the federated identity world, it would be the user authenticating with the IDP. Period. End of story. Yeah, the FIDO and IDP in that case is at that point in time of the overall flow is playing the role of FIDO relying party, and we have. I always rant about fully qualified terms, so thank you. So first you have to register yourself with the FIDO relying party, aka IDP, and that establishes the key pair and registers the public key. And the user experience is, that you go to the site, they say, why don't you get registered? Either you're creating an account because you don't have one, which is a standard thing that happens today. We use self-asserted credentials all the time. I go to foo.com and they say sign up. And so I say, here's my username, and I assert a secret key. This is essentially the same thing. You go there, they come back, they put up a UI, magic happens on the client, and you swipe your finger, and a public key gets registered at site.com and is in their account database. So we go to the next slide, please. And then later on you come back and instead of login and entering reusable shared secret, which is what your password is, you get a user interface that you swipe your finger and magic happens underneath the challenge that came over from the FIDO relying party, gets signed by the private key in the authenticator over here, and that message gets sent back. It gets verified using the public key on the server side, and Bob's your uncle. You're authenticated, or you're not. If there was a man in the middle. Okay. So the reason all this is relevant for the token binding stuff. Oh, and U2F. The only difference with U2F is that the user does supply a reusable shared secret, but it gets combined
with this asymmetric key magic underneath, and therefore neither the reusable shared secret nor the public key are reusable credentials in the sense of an attacker getting their hands on it, because the attacker would have to get the key store with the private key in it and be able to wield that also. So in terms of online phishing, it kills that kind of thing. Now, if you're targeted by some three-letter acronym agency and they grab your device with the key store on it, then game over. But for the vast majority of people, this is pretty cool stuff. And that attack also would work on UAF potentially. But they have to get your finger or whatever, biometric or whatever's being used. And so there were a bunch of design, and I didn't write. Yeah, so we needed to decouple user verification and authentication protocol to go. Oh, yeah, there's no third part. Keep going. Yeah, no secrets on the server side. Focus on privacy. Hold on, go down. So the whole idea is biometric stuff. Whatever is used on the client side, it could be a PIN entry, okay? What is, or it can be biometric. It doesn't matter. In the U2F case, it's a simple test of user presence that's asserted by the authenticator. There's no linkability between RPs because you're using different public keys with FIDO RPs, and thus no linkability between FIDO RP accounts. Okay. Right. Okay. Keep going. We wanted to decouple so there could be all these different user modalities. Yeah. Keep going. And this is the nominal UAF architecture. Keep going. Right, so we talked about all this. So the basic flow that we talked about. So, okay, stop. So why is this relevant here? It's relevant in this context because there are messages, cryptographic messages going back and forth between these parties, and it's going over TLS, and to minimize man-in-the-middle attack possibilities, you really want to bind the messages that are going at the app layer to your TLS channel. This is not news, right? That's why everybody's sitting here. And in fact, there's been in the specs, which you can go to filealliance.org and take a look at, you can use 5929, did I get the number right? The channel binding, TLS channel binding, though there's issues with that. That's why there's been work that Dirk's been doing over the years on what was previously called channel ID and is now morphing into token binding. So just as we were using OAuth as an example here of tokens that we would want to bind to a TLS channel, we want to bind these messages, aka tokens, to the TLS channel too. That's why the work in this room is relevant in all sorts of other use cases at a higher layers in the stack, up at the app layer. And that's why there's this, with the FIDO hat on, from the protocol designer's perspective, with the FIDO hat on, we need to have good, robust security token binding to the TLS channel. With the OAuth IETF hat on, or SAML or whatever, we need the same thing. So the work here has wide applicability. to security protocols that are happening at higher layers. And that's it.
So, John Bradley, one question, Jeff. So is the goal here to detect those helpful intermediate proxies, TLS proxies between the user's FIDO device and the FIDO relying party, and perhaps not allow those devices to get the user's credentials, because some people might call that a man-in-the-middle attack?
It's not a goal to detect them necessarily.
So is FIDO intended to work across those helpful enterprise TLS termination, session interception devices that may exist both on the enterprise side and have been detected, being helpfully deployed by a number of governments?
I have to look in a couple of places to answer that. I think the question would be if you just did a bare-knuckled implementation, that it would break, because that included token binding to the TLS channel, so you would see that there's a man in the middle, and you'd go, there's a man in the middle. And whatever you do about that, who knows? I think we have in the spec some weasel word allowances saying if you wanted to work across these kinds of things, you should do foo. I would have to look up what that hand-waving weasel word language and guidance is.
If you don't intend to actually do something about the tokens being intercepted by man-in-the-middle attacks, why bother detecting them?
Dunno.
Oh. Good answer.
I have to page all that stuff back in, and my drum memory runs really slow.
Okay, so Dirk just sent me some slides which we can put up. Okay, look, there's a FIDO meeting on this thing, Jeff.
I can stop waving at the camera and hand the mic off to somebody else.
Well, you can try.
Okay, let's try.
Only if the slides made it to...
Dirk.
Yay, all right. Pink box. So this is just one, I can go through that. One more level of detail maybe beyond what Jeff was just saying. So this is what we talked about an hour ago, right? How cookies, for example, could be channel bound. And the idea there is that somehow, and how this somehow in fact works in detail is what we're here for, but for this purpose, somehow the browser proves to the server that it's in control of a certain key, KB, and then the server chooses to associate a cookie with that key, KB. And that's what it means to bind the cookie to that client. Next slide. So in FIDO, what happens is that there's this thing called, that Jeff just explained, as the authenticator, which is sort of shown as a USB token here, because at Google they tend to be USB tokens, but they don't have to be USB tokens. It can be something that's built into your client device, maybe with a biometric fingerprint reader or something like that. But anyway, the abstract sort of generalization of it is we call it authenticator. And so at login time, what that thing is supposed to do, it's supposed to just sign a challenge. The server sends a challenge C to the client. There's a JavaScript API that allows the browser to pass that challenge to the authenticator, and then the authenticator's job is just to sign it with KU. It's called KU here on the slide. That's the user's key that has been previously been registered with the server. The server knows that KU is, stands for that user, speaks for that user. And so KU is supposed to sign the challenge. But so what happens is that as the JavaScript, the server's JavaScript, says, hey, I want you to sign a challenge, the browser will actually send the challenge to the authenticator along with the token binding key, KB, that it uses to speak to the server. And so what the assertion that the authenticator generates actually includes the challenge and the token binding key. So it's very similar if you think about a federation sort of use case, where this guy sort of would be the IDP, right? We were talking through how an IDP needs to know what the token binding key is so it can issue an identity statement that includes that. So the same is happening here, and the way that the IDP, in this case it's really the authenticator, gets to learn what the token binding key is because the browser just tells it. There's no crypto here other than that the browser just says, here's the public key, and please sign over that as well as the challenge. And then so I'm sort of showing that here as this curly brackets mean signature. And that gets just sent to the server, and so the server then checks that the public key that is mentioned in that statement that the authenticator generated is the same key that is used to authenticate the underlying connection. So that's how the token binding works in FIDO. That was it. Stepping off the box.
Okay, I hope that made things clear for everybody. You guys, well, we're going to add these slides to the materials page, so you guys can read them. And I think with that, we're done for today, and see you all in Prague. Yeah.
Yes.